Now let's look at quarterly. What's the difference? You know, the annual rate is 0.03. Each year we have 4 quarters. Then each quarter the rate will be 0.03 divided by 4. Okay? You can find out this value, 0.03 divided by 4. But again, my purpose here is to derive a formula. Okay, the end of the first quarter, at the beginning of the quarter, the first quarter, you have $100 plus $100 times the seasonal rate, okay, quarterly rate, 0.03 over 4. Take 100 out, same pattern with the left. Okay, 100 is out, you have a 1 plus 0.03 over 4. Okay, you may write 1 here, you may not, because here, no, that's the original expression. Okay, now at the end of the first quarter, you have $100.75. So the end of the second quarter starts at the beginning of the second quarter. You have this $100.75, and then plus this starting amount of the second quarter, the beginning of the second quarter, times the quarterly rate. Again, you can pull this number out. Okay. Then you have a 100.75 times 1 plus 0.03 over 4. Okay. Now this 100.7 is this one, but this one equals this one. So you want to replace $100.75, replace this quantity, 100 times that. That would be 100 times this quantity times this quantity again. So that would be 1 plus 1, which comes to be 2 for the exponent. And then keep 100 here. So at the end of the second quarter, you have 100 times 1 plus 0.03 over 4 whole quantity squared. You can do the end of the third quarter, similar pattern as we did here. But you know, at the end of the fourth quarter, you can do something like this, similar to this one. So I will skip the details. So the end of the fourth quarter, or you may say that's the end of the year, would be 100 times the quantity 1 plus 0.03 over 4 to the fourth. Now that's the end of the fourth quarter. Also the end of the year, so you have here is 4, here is 4. Okay. Now similarly to the things we did on the left or above, the end of the second year, that's the 8th quarter, you should have 8 here. 8 is 4 times 2. So the end of the second year, the exponent is 4 times 2. You can do more things right here. The end of the fourth year, that would be 16 quarters later. That's 4 times 4. So you will then have 100 times 1 plus 0.03 over 4 to the exponent, which is 4 times 4. Okay, so you can see at the end of the first year, Here is 4 times 1. The second year will be 4 times 2. The fourth year would be 4 times 4. The final answer is $112, 6992114. You can see this number compounded quarterly. This number is slightly bigger than that. So that's the advantage to calculate the interest quarterly. You get a little bit more. It's about 14 or 15 cents more. This number is greater than that. Okay, that's why compounded quarterly is better. Remember the pattern here. Here, compounded annually is actually 0.03 divided by 1 if you want to write. Compounded quarterly is 0.03 divided by 4 as an interest. Okay, and then here is 4, here is the number of years. Now, third one we want to work on is monthly. Okay, that pattern would be similar. The third one is monthly. Let me mark here is 3. Is 4 daily, and continuously will be on the right. Okay, monthly, the rate will be 0.03 divided by 12. Okay, let me put this comparison right here. Yeah, this is monthly, this is quarterly. Rate, quarterly rate is that, and then monthly rate is that. So previously we get at the end of the first year, you have a 100 times right here. At the end of the first year is 100 times 1 plus 0.03 over 4, the whole quantity to the 4 times 1. That's at the end of the fourth quarter or the end of the year. Now here 4 is 4 quarters, that's a year. So similarly right here, the end of the first year, you should have 100 times 1 plus 0.03 over 12 to the 12, because each year has 12 months. Okay, here each year has 4 quarters. You can write times 1, but you know you don't need. The end of the second year, here the rate is 0.03 over 4. Here is 4 times 2. That's the end of the second year. You follow the same pattern, you have the end of the second year. That's 100 times 1 plus 0.03 over 12 to the 12 times 2. Okay, because 2 years has 24 months. That's 12 times 2. Again, the end of the third year is 12 times 3. I didn't write here. You may add it right here. So the end of the fourth year would be 12 times 4. It's like here, 4 times 4 because 4 quarters. Here is 4, here is 4. Okay, here is 12, here is 12. 4 years we want to figure out at the end of the 4 years. So this is the formula for compounded monthly at the end of fourth year. The money we get here is $112, 0.7328021. And right here you see is 112.6992114. This 69 is slightly less than 0.73. So compounded monthly is better than quarterly. Okay, better than quarterly. Right. Now, how about daily? Daily, the pattern is the same. Okay. So look, the rate will be daily rate. That would be 0.03 over 365. That's the daily rate. Previously, here is monthly rate. Now, the end of the first year, previously was 12 months. Here is 12 months. And here is 365 days. Here is 365 days. Okay? So the end of the first year, you may multiply this 365 by 1, or you may leave it. That's the exponent. At the end of the second year, that would be 100 times 1 plus 0.03 over 365 to the 365 times 2. Here was 0.03 over 12 to the 12 times 2. So here is 365, 365. Here is times 2. Now you can see the end of the fourth year. Here will be from 2 to 4. You can do the end of the third year. That would be 3 here. So here is the end of the fourth year. So the end of the fourth year is 100 times 1 plus 0.03 over 365, whole thing to the exponent 365 times 4. The amount of money we get here is $112.7491292. This number, decimal part, is slightly bigger than 73. Here is 74. So compounded daily is much better. Not much better, but better than monthly. And monthly is better than quarterly, and quarterly is better than annually. Here we did daily. You may think about every half day, every hour, every second, and go to as small as you wanted.